Howdy, this tutorial video is going to help you with solving the area for a trapezoid for either of the bases. So specifically in this example, I'm going to solve for B1. You could call B1 B subset 1 or B sub 1, but basically there are two bases on a trapezoid. You have one at the top of the trapezoid and one at the bottom. So each of those bases has its own length. Okay, so we label one as base 1 and one as base 2. So that's what this 1 and 2 in the formula mean, is because there's two bases. Okay, so there's no math involved with those. These are basically a label for your bases. Okay, so the first thing I'm going to do is I am going to get rid of the fraction. That's what I personally like to try to get rid of first if I can. And we know that getting rid of a fraction can be done by multiplying it by its reciprocal. So if I had the fraction of 3/4 to get rid of it, I would multiply it by 4/3. That's its reciprocal. And the reason for that is 3 times 4 is 12 and 4 times 3 is 12. And they would actually cancel out. 12 over 12 would cancel each other out. Or you could have also canceled your 3's. You could have canceled without even solving it, and you could have canceled your 4's. So anytime you have a fraction and you don't like it and you would like to try to get rid of it, you may get rid of it by multiplying by its reciprocal. So here, if I have 1/2, I don't like it, I can multiply by 2 over 1 to get rid of it. But we know in math, we have to be fair and balanced to our equations. If we do something on one side, we have to do it to the other. So over here on the left, we have 2 over 1 times a. So you could either make them look alike by putting that a over 1, so they're both fractions. But we know by now any fraction with a denominator of 1 is just itself. So 2 over 1 is just 2. 2 times a is 2a. Okay, so what about the right-hand side? Our 2's cancel, our 1's cancel, and we're left with h. Base 1 plus base 2. Okay, so there's two ways that you could go about this from here. You could distribute this h into the parentheses. Okay, but I know that to get rid of that h, it's being multiplied, right? Being distributed means something is being multiplied. So to get rid of it, I can divide. So why would I spend all this time distributing the h into the parentheses when I see, hey, these are being multiplied? So why don't I just divide and get rid of the h and not worry about it? But we know if we do something on one side, we have to do it to the other. So we have 2a over h equals, your h's cancel, my screen got all messed up on my end. Just a second. Okay, there we go. And then we're left with base 1 plus base 2. Okay, so it said in the original problem, solve, oops, that's not my highlighter tool. It said solve for base 1. So that means we want this base 1 to be isolated. If you were supposed to solve for base 2, you're going to do the opposite of what I do right now. So if I see here, I want base 1 to be by itself, or b sub 1. So that means I need to get rid of this plus b2. Well, how do we get rid of something that's being added? Or how do we cancel out something being added? We do the opposite. So we are going to subtract b sub 2 from both sides. Okay, so I had what was already on the left, and I subtracted b sub 2 from it, or b2, base 2. Okay, hope that helps.